Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So as per the problem, a rectangular piece of land is to be fenced using two kinds of fencing. So two opposite sides will be fenced using standard fencing that costs $6 per meter, while the other two sides will require heavy duty fencing that costs $9 per meter. What are the dimensions of the rectangular lot of greatest area that can be fenced for a cost of $9,000? So in this problem, we have to analyze a rectangle, and in that rectangle, the opposite sides will be fenced the same way. So one pair of opposite sides will be fenced using standard fencing, and the other pair of opposite sides will be fenced using heavy duty fencing. So let's start by drawing a diagram for this piece of land. So we have to draw a rectangle. So let's assume this is our rectangular piece of land and the two opposite sides. So let's assume the length of this rectangle is x. So the other length is this one. And let's assume these two opposite sides are fenced using standard fencing, and the cost of that is $6 per meter. And let's assume the width of this rectangle is y, and these two sides are fenced using the heavy duty fencing, and the cost of that is $9 per meter. Now we are given that the total cost of money that will be spent for the fencing is $9,000. So that means the sum of the cost of fencing these four sides should be $9,000. So now we'll have to write an equation for this total cost. So the cost of fencing this x meters of length using the standard fencing will be 6x. And then 6x will be the cost of fencing the other length. And now the cost of fencing the width y will be 9y. And it will be the same cost for the other width. Now the sum of these four costs should be equal to $9,000. So this should be the cost equation. So now we can simplify this equation by combining like terms. So 6x plus 6x is equal to 12x, and then 9y plus 9y is equal to 18y equals 9,000. Now we can reduce this equation by dividing each term by 6. So we get 2x plus 3y equals 1500. Now we have to find the dimensions that can enclose the greatest area. So we have to analyze the area function for this rectangle. And we know the formula for area of a rectangle is length times width. So it will be xy. So this area formula has two variables x and y. So now we'll do substitution using our cost equation. So from this equation we can isolate y and then do the substitution in the area equation. So we can isolate y by subtracting 2x from both sides. Now in this equation we can isolate either x or y and do the substitution for that variable, but I'm just isolating y, but you can also do that for x and do the substitution for x. You'll get the same answer as the final answer for this problem. So we get 3y equals 1500 minus 2x, and now we can divide each term by 3, and that gives us y equals 500 minus 2 over 3x. Now we can do the substitution for y in this area equation. So we get area equals x times, so we'll replace y with 500 minus 2 over 3x. Now we can distribute the x in parentheses. So we get area equals 500x minus 2 over 3x squared. So this is the area equation in terms of just x. Now we can write the domain for this area equation. So we know x represents the length of the rectangle, so x has to be greater than 0. Now for the upper limit, we'll have to analyze the cost equation, and the cost equation we got was 2x plus 3y equals 1500. Now x will be a maximum when y is equal to 0, because y cannot be a negative number, so the lowest possible value for y is 0. So if we sub in y as 0, so we get 2x plus 0 equals 1500, and then we get 2x equals 1500, and now we can divide both sides by 2. We get x equals 750. So this is the upper limit for x. Now it cannot equal 750 because at x equals 750, y is equal to 0, which is not possible because that means the rectangle won't have any width. So x should be less than 750. Now we have to find the derivative of this area function in terms of x to find the x values at which the tangent is horizontal, because at maximum area the tangent should be horizontal, because maximum area will be the point at which the peaks are formed in the graph of this area function. So we'll start with, so prime of a equals, so the derivative of 500x will just be 500. So 500 is the coefficient, so it will stay as it is, and the derivative of x is 1. So 500 times 1 is 500, then minus 2 over 3. So 2 over 3 is the coefficient, so it will stay as it is. And as per the power rule, the derivative of x squared is 2x. Now we can sub in a prime as 0. So 0 equals 500 minus, and 2 over 3 times 2 is 4 over 3, and then x. So now we have to solve for x. So we'll move this 4 over 3x to the left side of the equation, and that will make it positive. So 4 over 3x equals 500. And now we have to solve for x by cross multiplying the 3. So we get 4x equals 500 times 3, which is equal to 1500. And now, so we can just move here. Now we have to divide both sides by 4 to isolate x. So the 4's on the left side will cancel each other out, and we get x equals, so 1500 divided by 4 is equal to 375. And the unit will be meters. So this is a valid value of x because it lies in the domain of the area function, which is from 0 to 750. Now we'll calculate the area of this rectangle at 3x values, x equals 0, which is the lower limit for the x, and then 375, and then at 750. So let's start with area at x equals 0. So a at 0, so we'll sub in x as 0 in the area equation, which is this equation. So it will be 500 times 0 minus 2 over 3 times 0 squared. So a at 0, so both terms will be equal to 0, so the area at x equals 0 is equal to 0. Now we can calculate the area at x equals 375, so we'll use the same equation. So 500 times 375 minus 2 over 3 times 375 squared. And now we can evaluate this expression. So 500 times 375 is equal to 187,500, and then minus 2 over 3 times 375 squared. So I got 93,750. And now we can subtract these terms. So area at 375 equals, so 187,500 minus 93,750, which is equal to 93,750. And the unit will be meter squared. Now we have to calculate the area at 750. So we'll use the same equation. So 500 times 750 minus 2 over 3 times 750 squared. So a at 750 is equal to, so 500 times 750, which is 375,000, minus, now we have to do 2 times 750 squared divided by 3, which is another 375,000. So area at 750 equal to 0. Now we have to find the dimensions for greatest area, and we got that for x equals 375. So the final answer will be x equals 375 meters. Now for dimensions, we also have to find the y value, and for that we'll use the equation in which we isolated y, and that's this one. So y equals 500 minus 2 over 3, and we'll sub in x as 375. So now we have to evaluate this expression. So 500 minus, so which is equal to 250, and now we have to do 500 minus 250, which is equal to 250, and the unit is meters. So these x and y values are the final answer for this problem. So these are the dimensions that will maximize the area for a fence that will cost $9,000. So 250 meter by 375 meter. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.